Such a feeling's
Good
coming
morning, good
over
afternoon, good evening,
me.
whatever the case may be. We
There's wonder
are back
amongst
and better than ever, and today
everything
we
I
are talking about
see.
laws of
Not
logarithms,
cloud in the
continuing
sky,
our
got the
exploration
sun in
into
my
logarithms,
eyes, and
why
I
we need
won't
them,
be
how we
surprised
deal with
if
them, how we
it's a
can solve
dream.
logarithmic equations, what they're for, and
Everything
the
I
importance
want
of
the
them.
world to
So,
be
as
is
the
now
beautiful
coming
voice of
true,
Karen Carpenter
especially
from the
for
Carpenters
me.
goes in the
I'm
background,
the reason
we will
it's clear
continue and
it's
turn her
because
down. Unfortunately, we'll get back to that in just a second. Let's get to it, shall we? All right. So we got our laws of logarithms here. What I have for you is what appears in our book, and then what appears on your formula sheet. They're the same. Cap letters here, small letters here. But I just wanted to point a couple things out. If I have two logarithms, I am adding them and they have the same base. That's equivalent to multiplying the arguments. So log A plus log B is equal to log AB. That is similar to x to the A times x to the B is equal to x to the A plus B. And here, log A minus log B equals log of A divided by B, similar to x over A minus, or I'm sorry, similar to x over A not x over A, x to the A over x to the B equals x to the A minus B. And then we have this relationship where n, some constant multiplied by a log of a, can be rewritten as a to that exponent. That is very, very useful. Those are all right here, laws of logarithms right there. And we will use all of those today. We'll get to change a base later. Here's some proof for those laws. We can talk about that in class. You can read through them also if you would like. So, a couple of examples. Okay. Use the laws of logarithms to write the following as a single logarithm or as an integer. Well, log 5 plus log 3, those are both base 10. So that is equivalent to log of 5 times 3, which is simply log 15. Okay, and that's this law right here. Log base 3 of 24 minus log base 3 of 8, since it's subtraction using this law right here, I can write that as 24 over 8, which is equal to log base 3 of 3. Ooh, I have a logarithm with the same base as the argument, and the power is 1, so that is equal to 1. Let me just point something out real quick that folks get mixed up all the time. Log 5, log 3 is not equal to, like if these are being multiplied, that's not equal to log 15. Okay? That's not equal to log 15. It has to be in this form. And log of 24 over log of 8 is not equal to log of 3. And it's not equal to log 24 minus log of 8. You have to be sure you see the differences there. Log 24 minus 8 is log of 24 minus log of 8. It's the 24 divided by 8 that it turns to, not this. Same thing here. Okay. Here, at first, it looks like that we're really not going to be able to do anything, but we got a base here of 2 here. So log base 2 of 5 minus, I can always write 1 with logarithms using the same base as the argument. And I chose 2 because the first base was 2. I could have used any base. Log base 2 of 2 is 1, just like log base 3 of 3 is 1. As long as the base and the argument are the same, then it's going to equal 1. And I choose 2 because that's the base of the first one. So again, using the subtraction law, I get log base 2 of 5 over 2, which I can write as, yeah, just like that, 5 halves. I could even write 2.5 if I would like to. Okay. Next, simplify by writing as a single logarithm or as a rational number. Okay, so this is the first time we're going to use our exponent rule, which is right here, and it says that if I have a coefficient in front of a logarithm, then I can make that a power of the argument. So log of 7 squared minus log of 2 cubed. So the 3 goes and becomes an exponent, the 2 becomes an exponent. So that's log 49 minus log of 8. They both have the same base. So I can write that as log of 49 over 8. Okay, so we're learning how to manipulate logarithms to be able to do that to solve some problems later. So here we have equals log base, it's a base 10, so that's log of 3 squared. Now my base is 10, so I'm going to rewrite this 3 as same idea as before. I can rewrite this as log of 10 cubed, because remember there's really a 10 here, and the logarithm of something with the same base, of the argument with the same base, is equal to the exponent. Okay, and I chose base 10 because this one was in base 10. So let me get rid of that because we know it's there. So then this becomes log of 9 plus log of 1,000, 10 times 10 times 10. And then I can rewrite that as log, since it's addition, using my addition law over there, of 9 times 1,000, which is log of 9,000. So we've got that. Ooh, and what about these? Well, we're going to use our exponent rule backwards, so to speak. Remember, this is a good example. This is not this rule because it's not log of A over B. It's a log of something over the log of something. It would have to be the log of 8 over 4 is equal to log 8 minus log 4. Okay, but not log 8 over log 4. Log 8 over log 4 does not equal that. Okay, so for this one, we are going to say, I'll move down here. I'm gonna, both the 4 and the 8 are both base 2, so that's going to be helpful. So I have log of, let's see, I can write as 8 as 2 cubed. And I can write 4 as 2 squared. And watch what's going to happen here. I can now move these in front, 3 log 2, over 2 log 2. Now, the log of 2 is a number. The log of 2 is a number. So those cancel out because of the multiplication here. And I'm left with it being equal to 3 halves. Okay, a few more. Lots to do here. Show that log base 10 of 1/9 is equal to negative 2 log 3. Okay, so I think I'm just going to work with this one. Log of 1 over 9. So that's equal to log of 9 to the negative 1, which is equal to log of 3 squared to the negative 1, which is equal to log 3 to the negative 2, 2 times negative 1, and again using my exponent law here, I can move this exponent out front as a coefficient, and there we have it. I've shown it. Okay, so now let's try this one. I'm going to work on log 500, so let's see. Log 500, I can think of that as log of 1,000 over 2, which is equal to log 1,000 minus log 2. Now, how did I think of to do that? Well, I saw the minus, So I was thinking of my subtraction here, my subtraction law, and I thought of, okay, well, 500 can be written as 1,000 over 2, and looking ahead, along with my subtraction law, I knew I would get a log 2 here. Also, I saw that 10,000 can be written as 10 cubed minus log 2. And since this is base 10, log base 10 of 10 cubed is equal to 3 minus log 2. Boom. Chugga-lugga-lugga-lugga. All right. Moving forward. So they're saying write these as logarithmic equations in base 10. This is really, really important to be able to do this. So the way that you can take a Cartesian equation and write it using logarithms is you take the log of both sides. So it's basic equation solving. I can do the same. I can do this as long as I do it to both sides of the equation. Okay, so it says write these as logarithmic equations. And right now they're really logarithmic equations, but I'm going to expand them all the way out just to show how far we can go. So log y equals, I've got the product of two arguments, so I can write that as log a squared plus log b. That's using this law right here. And then log y would be equal to, using my exponent rule right here, 2 log a plus log b. Boom. Done. Okay. And let's see, what do we got here? So for b, I'm going to have to start labeling these. I'm running out of room. Log of y is equal to log of a over b cubed, which, so log y is equal to log of a minus log of b cubed. There I use my subtraction rule. So log y is equal to, finally, log a, and I can move my exponent down as a coefficient. Okay? And then the last one, c. So p equals 20 over square root n. So I'm taking the logarithm of both sides. So log p is equal to log of 20, and I'm going to go ahead and just do it now and write root n as n to the 1/2 power, because that gives me an exponent, and eventually I'll be able to use my exponent rule or law. Log p is equal to, I've got a division of two arguments, so I can rewrite those as the difference of two logarithms. So log n to the 1/2, and hopefully you can now see that this will turn into log p is equal to log 20 minus 1/2 log n. That didn't look like much of an exponent there. I should have put n to the 1/2 so you could see. I think you could see it there. All right, last page of examples. There's just two of them. So now they want us to write the following equations without logarithms. Okay, so I have log a equals log b plus 2 log c. And in order to do that, I am going to, what I'm trying to do is going to get log of something equals log of something else. Then the two arguments must be equal if they are to be equal with one another. So I can't really do anything with log a, so it's just going to hang out for a while until I get these together. So this would be log b plus log of c squared, exponent law. Log a would be equal to log of bc squared by the addition law right here. And if I'm taking the log of something and I want it to be equal to the log of something else, these two must be equal. The arguments must be equal. So now I have a must be equal to bc squared. No logarithms involved. Okay. So here we go. Log base 2 of m equals 3 log 2 of a minus 2. So I will continue with log base 2 of m is equal to log base 2 of a, move the coefficient to be an exponent. And so I am in base 2. So I'm going to rewrite 2 using base 2, which would just be log base 2 of 2. Now if I left it like this is now equal to 1. But if I make the exponent a 2, then it's equal to 2. So now we're getting somewhere. Log base 2 of m equals log base 2 of a cubed minus log base 2 of 4. I guess I could have simplified that before. So log base 2 of m is equal to log base 2 of a cubed over 4 using my subtraction law. So once again, I have the logarithm of the same base equal to another logarithm. So those two arguments must be equal. So I can now say that m is equal to a cubed over 4. Okay. So those are some ways we can manipulate equations and expressions of the logarithmic variety. I hope you enjoyed it. It will be quite useful to you. And as promised, back to the Carpenters, the great Karen Carpenter. And with that, I am on the top of the world. And I am also out. Is the love that I found ever since you've been around. Your love's put me at the top of the world.